All right, good people. Well, the first topic we're going to be taking a look at is, as promised, factoring, prime factorization. Okay, so what I got here, you can see on the left side here, some pre-created notes, and on the right side here, hopefully this can work out where I can do the writing and such here for you to see. Feels good with the hand. More natural writing environment than like those digital computers and such. Okay, so we'll take a look at this, make sure it works. But what do we got here, math-wise? What do we got is each of these numbers here on the left can be rewritten as a product, which in math means multiplying, or more precisely, the answer from multiplying. Okay, so the answer for multiplying two or more numbers is our starting number here. So number 6, that can be written as, of course, 3 times 2 is one example. So the 3 and the 2, these are factors of the 6. 12 can be written in a few ways. 3, 4, 6 and 2, 12 and 1 as well. That's not there, but also legal and possible. And what I'd like you to notice for the purpose of this topic is that 12 can also be rewritten not just with 2 numbers, but or more numbers. Right? So what we can do is we can just notice here that 3 times 2 is 6, times 2 is 12. And then all of these numbers are prime, as we mentioned in the prime style they mentioned in the beginning. 91, 7 times 13. Right? And this is importantly what kind of makes this topic interesting is that, yeah, you got to know a bit about numbers. You see, mentioning the password, if you didn't know that 91 can factor to 7 and 13, well, then the password is unknown. The secret stays a secret. But with a little bit of math, you can say, oh yeah, this factors to 7 and 13, and now you know the secret number to continue. All right, so just a reminder about some vocabulary for you and prime factorization. This is where you rewrite a number using prime numbers only. Prime numbers are the list is started there, and all it shows is that you have the factors of 1 and itself. The number 2 has the factors of 1 and 2. Nothing else. 13, 1 and 13. Nothing else. Prime numbers. Okay. Now, what's interesting, what's important is that each number can be written with all primes. And by the way, I'm going to say if a number is not prime, because you might be asking yourself, it's called a composite number. Okay, so for example, 12. Are the factors 1 and 12 only? No, not a chance. We saw 2 and 6 and 3 and 4, right? So this number is called a composite number. On the screen, you can see all the numbers on the left, 12, 18, 100. Those are all composite numbers. And then they can all be written with prime numbers in their own special way. Now for us, the goal is to figure out what these special numbers are. And so there's 2 ways that, or at least I'm going to show you a couple of ways that you can do this. Okay, one method is called the factor tree, and another one is repeated division. Okay, but just as a cute little example, right? And if our password is, or applying this topic, if in order to get the password, we got to figure out the largest prime number from this group here, okay, if we can figure out, hey, then we can get into the secret door. We can continue. Our phones can connect. Our bank accounts can do their work, right? If you don't know the number, stay secret, secure, protected. Okay, well, let's show you how factor trees work. If you took a look at the videos ahead of time, then I think you know what to expect here. Looks like this. Start with a number at the top, and then what you do is just figure out two numbers that multiply together to give you 18. Multiply together to give you that number. So nothing really special to think about with squares or anything like that right now, but just two numbers that give you 18. I'm going to say 2 and 9 just because. You could say 3 and 16 or 3 and 6 if you like. Doesn't matter. In fact, we might actually do it just to show you. See? And then once you have those down, you do the next one. And what two numbers give you 9? 3 times 3. And so what is the prime factorization of the number 18? 18 is the same as 2 times 3 times 3. And I'm not sure if you asked, but I did mention it. If you happen to start a different way, use 3 and 6 instead, you get 2 and 3. Right, so what happens? You get 18 is the same as, you can put the numbers in order from smallest to largest and, group them together. So you get 2, 3, 3. So you happen to get the same batch of numbers, the same group of numbers, right? To multiply together to give you that. The fingerprint. Unique, right? Nice. That's what prime factorization for 18 would be. Doing the same for 100. On your marks, get set, go. I get 100. 10, 10 sticks in my brain first, so I'll just do that one. 10 times 10 is 100. 2, 5, 2, 5. Put them all together. 100 is, yeah, again, you can put them in order. Smallest to largest like that. I like to start creating the prime factorization. The special list. The special combination of prime numbers. And then the last one, see, start getting big. The password gets a little more tricky, or not tricky, but perhaps harder to find. 424. I don't know, too big for my brain, so I'm going to say 2. 2 goes into there. I get 212. Thankfully, 2 again. And so what I got, what happens in here? We got a 10, where it goes in 1, a 0, and then a 6 like that. And then this breaks down to a 2 and a 53. And see, now you got to know stuff. Is 53 a prime number, or is it finished? Can we go more? Well, for free, I'm going to tell you that that's it. Okay, so for 424, the prime factorization is 2 times 2 times 2 times 53. And so now, that shows you the factor tree method for creating the prime factorization of a given number. But now we got to figure out what this the secret password. What does it say? Largest prime number from all of our work that we had. Okay, well, what was the largest number from 18? Prime number. from 18. I think we had, that was 2, a 3, and a 3. So the largest is going to be 3. From 100, that was the same as 2255. So the largest is 5. From the one we just did, 424, that was a bunch of 2s and a 53. So the largest is 53. Okay. And so interestingly, it took some time for that. Right? So it took some time for this to happen. That's part of the secrets of security. Right? But after some time, which one's the largest? 53. So you punch in the number 53 and success. Right? You got the password. You can get in and do whatever it is you got to do. Okay, so we now use the same numbers just so we can compare the answers. But really, this is just a different style, different way of organizing the information. And that idea can be useful. Sometimes you can see patterns if things are arranged a certain way, and rather than some other way. Okay, so just to show you how repeated division works, it just makes a ladder, basically a straight line up on top. It's all drawn in a straight line rather than a bunch of branches. So the way it works is you ask yourself, what number divides into 18? Well, 2. 18 is an even number. Even, by the way. 2, 4, 6, 8, 10, blah, blah, blah. Odd. 1, 3, 5, 7, 9, blah, blah, blah. Odd number. 18 divides by 2, what do you get? 9. Now you ask yourself again, what number divides into 9? See, you just write it like straight up and down. 3 divides into 9. All right, well, what do you get? 9 divided by 3 is 3. And then what you want to do is you want to finish this off all the time. Okay, so what number divides into 3? Clearly, 3 only. And by finish off, I mean, you go 3 divided by 3 is 1. Finish with the 1 down there. Then when you look on this side, that is the prime number factorization there. Okay, so 18 is just like before, 2, 3, and 3. Prime factorization. So straight up and down, end at a 1. What can you divide with? 100. Same style. Straight up and down. We saw the answer was 2525 or 2255. What divides into 100? 2 for sure. It's even. Oh, and I might add, when you're doing this, choose prime numbers. Okay, that's actually important. All right, I mentioned that because I was thinking, oh, you could put 10 there. 10 goes into 100 and you write 10 down. No, what we'd want to do, the goal is to break it down to prime numbers. So important, use prime numbers when you're creating this vertical part here. 100 divided by 2, 50. What prime number goes into 50? I'm going to say 2 because it's true. You divide and what do you get? 25. What prime number goes in? 5 goes into 25. You do the dividing, what do you get? 5. Okay, one more time. What prime number divide? Clearly it's 5. And then 5 divided by 5 clearly gives you the value of 1. So the prime factorization of 100 is 2255. Repeated division stylings. We can also do the same for 424. What prime number goes into both? Both. That's a different method. What prime number goes into 424? 2. 212. What prime number goes into 212? Goes into means divide, by the way. Same as divide. So 2 divides into 212. What do you get? 106. What divides into 106? Prime number divides 2. What do you get? 53. Finished? Yeah. Okay. Divide by the 53 to get the 1. 1 means done. It rhymes. It's a good way to remember it. So what's the factorization? We got 424 as 2 times 2 times 2 times 53, as we saw in the earlier question. Just a different style there. Okay, now notice, as the numbers get bigger, we can start to get quite a big list of prime numbers. And so, to help with the writing, we can use exponents along the way in order to just create a little shorthand, actually, and then allow us to get into practicing some sophisticated algebra. So just a reminder about how exponents work. On the left, you can see you have, don't want to move it, but you got a 1, you got 1, 2 there, 2 2s, 3 2s. So how many 2s are multiplied together? 3 2s are multiplied together. Right? 3 2s there. And the next example down, how many 3s are multiplied together? There are 4 3s. So 4 goes upstairs like that. How many 10s? 2 10s. Now, a thing to watch is when you get these negatives, okay? So on the left here, we have -2, -2, -2. So the thing we're working with is -2. So that means it goes inside a set of brackets. How many are there? 3. So the exponent is 3. Here it's all jumbled, but just as a reminder, with multiplying, we can switch the order because the results are the same. And so we do that. Put the 2's together, put the 5's together, and we can get the exponential expression looking like this, because we have 2 5's that are being multiplied and 2 2's that are being multiplied. All right. Similarly, this one here, almost related to our example with the 53, but I think we had 3 2's in the other one. And this example here, only 2 2's. So just a little 2 upstairs for the exponent. And by the way, I am using the words like you know them. Maybe I should point out this number down here is the base, and that number up there is the exponent. And sometimes the word power is used for exponent as well. Okay, so looking at the first example, this is -2 to the power of, how you say that? To the power of 3. This is 5 to the power of 2. 2 to the power of 2, right? the exponent shortcut can also work with letters. Right, 12 we've broken up before into prime factorization, or no, we didn't do it, but it was given to us. And I think we could all agree that the answer there is true and correct. No lies being told there. 2, 2, 3. How many 2's are multiplied together? 2 like that, 3 like that. Right? The n squared, what does that mean? Oh, so squared is the way to say when the exponent is a 2. So n to the power of 2, or n squared. That means there are 2 n's multiplied together. And that's what we have over on the left screen there, n times n. Okay, so this thing here, that's the prime factorization for 12n squared. Okay, all the way down to the prime numbers, all the way down to the basic individual letters. This thing here, it's kind of a side topic. If you wanted to put this into, put exponents into a computer of some sort, like Desmos as we used for homework, then this is the symbol that you use in order to show an exponent. Okay, so you go n, I think that's called a caret or accent aigu in French. So you put that in there, and then the computer understands what that 2 is. It understands that the 2 is the exponent. Right, and then it knows how to, it will know how to graph this thing accordingly. All right, good people. Well, that takes care of the introduction into prime factorization, which means you can do the first couple of sheets that are available in the teams for homework. And what we'll do is we'll close this video and then go on to the third part, which has to do with working with radicals, square roots, cube roots, or surds. All right. Thank you for stopping by. I will see you shortly.